Hello out there. I hope you're ready to look at some statistics on this beautiful day, okay? So what we're going to do today is actually calculating the correlation. How do we calculate this correlation? And still look at the meaning of this correlation, okay? And doing your maths out there, remember, I'd like you to try some of the questions with me. Have your calculator with you and try the problem. It's not about observing only, it's try to do the mathematics behind, okay? Let's see what we have, okay? So what we're going to do now is some of the keywords is correlation, standard deviation, and mean. What is correlation? Okay, we spoke about correlation. Correlation is the association between two variables. Okay, an example I can think about is the oil price and petrol price. If oil price goes up, the petrol price goes up. So there is a positive correlation between the two because the two moves together up. Okay, and negative correlation, if one moves up, the other moves down, okay? It could be something like this. Inflation, remember that inflation, if inflation increases, the power of money decreases, the value of money decreases. So there's a negative correlation between inflation and the value of money, okay? So that's the correlation. And what is standard deviation, okay? Remember, the standard deviation is the average deviation from the mean. And remember that the mean, when I talk about the mean, we talk about the average, denoted by X bar, if you remember. The average is the mean, is the average bar. Is how far are you from the mean, okay? If I have a set of data, the average is take everything divided by how many numbers we have. That's the average, the mean. Standard deviation is how far are you from the average. It's the deviation average from the mean. Okay, that's the standard deviation. Okay. Then the mean, just spoke about that, is the average. But we have two different kinds of mean, group data and raw data. Raw data is data given like 1, 2, 3, 4, 5. It's raw data, okay? To calculate the mean for raw data, I just add all the data divided by the sample size. But where group data, it could be boys between 10 and 5. What is their shoe size? Boys between 10 and 15. So the data is grouped. And to calculate the mean, we use midpoints. Okay, so the mean is the average, could be raw data, could be the mean. Okay, so I'd just like you to remember what is correlation, standard deviation, mean, and the mean. Okay, so we're going to look at correlations now again. So what is correlation? So correlation is the linear correlation coefficient. So we're going to calculate this coefficient. How do we calculate this? So it's denoted by letter R, which is the correlation. It's a measure, okay, it's measure something, quantify something. So this measure, which tells us the strength and the direction of a relationship between the variables. Very important. It tells us the strength and the direction. The strength means the association. And the direction, we're talking here about whether it's negative or positive. Positive moves together. Negative, if one moves up, other moves down. Okay? It's the strength and the direction. So the correlation coefficient is between -1 and 1. So the value of the correlation coefficient, can I come with a correlation coefficient of 2? No, because 2 is not between -1 and 1. But can correlation be 0.7? Yes. Why 0.7? Because 0.7 is between -1 and 1. Can correlation be -3? No, it can't be. -3, I mean, so it's from -1 to 1. -3, it's smaller than -1. It's not in that range between -1 and 1. Correlation coefficient is between -1 and 1. That's it. We're together, guys. Fantastic. Now, correlation coefficient, we said, is between -1 and 1. So when R is -1, there is a perfect negative correlation. Okay, it's a perfect negative correlation. But what about when R is 0? There is no correlation. There's no correlation. There's no relationship between the two variables. But if R is 1, there is a perfect positive correlation. Okay. -1, negative, perfect correlation. 0, no correlation, no association between the two variables. 1, perfect correlation between the two variables. Now, what are we going to do? We're going to use the simulation, okay? The simulation, what we're going to get is our y there, which is our dependent variable, our x, which is independent variable, and to plot some point there and really estimate the correlation. I would like you to estimate in your head first before the simulation can really tell us what is the correlation. Let's look at what does that look like, okay? So there I am here. So what I would like us to do, okay? So here what I'd like us to do, we have -1 correlation. There is a line with -1 correlation. So we can see it's -1. What does -1 mean? It's perfect negative correlation. What must I do for me to get 0 correlation? What must I do? Let's look at what we must do to the points. If I move the points from the line, let's see what happens. If I move, what happens? Let's look at that. What happens? The correlation. Let's look at that. What has happened to the correlation? I'm moving all the points. Can you see? 0.27 now. I want to make this close to 0 as possible. 0.23. It's increasing there. Yeah, there. Almost there. We're getting 0. Correlation is 0. What does that mean? There's no relationship. Look at this. We can't even draw a line, a straight line that is close to those points. Okay. What about, how does this line look like if R is -1? -1, so our points will be going down. Are we together? Let's look at that. Something like that. Let's see there. Because I'm getting a negative relationship. Let's look at that. Let's move that point somewhere there. You look at this. Can you see this is strong? Why strong? -0.98, close to -1. So that's strong negative correlation. Are we all together? So that's a negative correlation. So but a positive correlation, what must happen? Positive, we'll have to move our lines this way. Let's do that. Let's do that because I can get a straight line, which is positive. Can you see that? My correlation changing from negative to positive. Can you all see that? So what is happening here? 0.98 positive. Strong positive correlation. Okay, beautiful. Now, let's go back and see what we have here. So this is what we had by looking at simulation. So Now, what we're going to do is to look at whether does correlation exist. We're going to look at a plot and say, does correlation really exist? Okay. What we're going to do, we're going to look at that after the break. What I'd like you to do during break is to think about this. How will I tell whether correlation exists? Take that time. After the break, we're going to look at how do we see that, okay? See you shortly.